hamsci. So this week, I've been helping Dave Witten with some magnetometers testing and plotting, as well as doing some of my own other programming. Also, work has raised its head. We have a book with Springer that we're getting kicked off, and I'm one of the editors. So just more work, that stuff happens. But that's what I've been doing this week. So next on my list, according to the participants, I have Nathaniel. Go ahead, Nathaniel.
Thank you very much, Dave. I've been continuing my work here in Scranton, reading about ionospheric and lower atmospheric coupling, coming up with really nerdy jokes about atmospheric climate models, and working with Dev, trying to get the GPS disciplined oscillator up and running for his ZS200, which we are still working on, but we'll get there eventually, and working with Veronica on coding and ham radio things. W2NF, back to net.
Okay. Next on the list, I have Scotty, WA2DFI. Scotty, are you ready?
Sure. Thanks, Dave. Good evening to everyone. I'm free now. No more moving.
Yay.
No more sweating outside. It's like, what is it, or like this? No, one of these is bad. I forget which one it is. One of them is a good victory symbol, and the other one is anyway. So now I'm pretty much going to be full-time on the Tangerine project. So, and one thing I did not mention last week that happened was that TAPA received a check for the ARDC grant. Yes. So we are all funded up and ready to go. I talked to Nathaniel a little bit earlier today about the magnetometer bill and came to the conclusion that we need to wait for Dave's results that he's working on. There was a resolution of the performance before we build anything in quantity. So I think discretion is a better part of. And I hate to have a whole bunch of them built and then find out we had a problem. So we'll wait. But the gun is cocked and ready. It will be only 3 weeks from the time we say yay to the time we can actually get them when we're ready. So we'll hold off on that. And I think that's about it from here, other than I get to rest up now. So back to you, Dave.
Well, congratulations. Next on the list is Bill, AB4EJ. Go ahead, Bill.
Well, thanks, Dave, and good evening to the net. And Scotty, glad you got that stuff out of the way. I've got it working now where I can run FT8 and 48 kilosample using flex data, but I found out, okay, 48 kilosample is basically simulating 6 8 kilosample channels. That's the amount of data, and it seems like pushing all of that through a single port on the Odroid seems to result in loss of data. Of course, UDP, that's fine. So, but it's not fine for us. So, I think I'm going to try and find a way to set up a second set of ports for FT8, which I wasn't wanting to deal with multiple channel sets for this version of this thing, but I might have to support at least 2, one for the regular ring buffer stuff and one for FT8. As far as processing the FT8 stuff and the ring buffer stuff, I bought it's a Western Digital Purple drive that's for video surveillance systems. It's supposed to have a very high number of write cycles possible for it and an enclosure to go into it. And I found out that the Odroid will run indefinitely, riding up a storm to it. So at least we know that that part works fine. Also, I came up with some ideas on how to do what we think of as the fire hose approach the fire hose mode, I'll probably make this configurable where people can configure this to go either to their hard drive or to RAM buffer. If you have plenty of upload bandwidth, probably the right thing to do for the fire hose system is to save the data to the RAM buffer and then push it up from there. That way you're not consuming all the resources to push everything to disk. But of course, you can fill up the RAM buffer a lot quicker than you fill the disk. So we're going to have to give people some guidance on how to configure their system. I'm making a lot of these things configurable, and also with an option to where if you mess up your configuration, you can restore to factory defaults. So anyway, okay, that's my report. Back to Ned.
Very, very good, Bill. Next on the list, we have Dev. Go ahead, Dev.
Hello, thank you for the opportunity, David. So we have been continuing to work to install our ETOS device. It is going good so far, but right now we're trying to confirm that the motherboard in the device is reading the timestamp of the GPS DO that we're trying to install. So I am confirming the presence of GPS DO, but I'm yet to find a way to read the attributes of GPS DO and to have the motherboard get the time stamp from the GPS DO. So that's the agenda for me and Nathaniel to have that done as soon as we can, I think. So that's where we stand. Thank you.
Very good. Next on the list, we have Dan. Go ahead, Dan.
Thank you, Dave, and hello, everyone. Well, I'm operating at a little bit of a deficit this evening. My main computer took a dive yesterday, and I ordered a new power supply for it, so hopefully that will take care of the issues. Anyway, I'm operating off of a laptop, so the picture isn't quite as good. Voice is probably about the same. Not much going on. I worked a little bit on scripts last week. Did have one FL Digi that changed versions. So if you have 4.1.13, it isn't going to work anymore. You need 4.1.14. Also did some exploring on how to change the timeouts for sudo. Right now, I think it by default runs either a 5 or 15 minute timeout, depending upon whether on the system that you're using. But there is a way to change that. And you can actually go into a file in the Etsy folder and do a little bit of manipulation and change it. What it does is it actually wants you, with the scripts, if you don't use a PI, and if you need to actually confirm sudo with a password, it will do part of the script, and then the next time it comes up against a requirement for a sudo command, it will ask you for the password again. And I'm trying to get around that. I thought there might be a way to just not do that, but in thinking about it, it would really break your system or break the security part of your system if you bypass that. I mean, sudo is good for something. And even though it's kind of bypassed on Raspberry Pi by default, on most systems, it's very beneficial to have it. Anyway, that's about it from here. Back to you, Dave.
Fine. And I did try some of your made Ubuntu scripts, and they worked fine. And I didn't seem to have real problems. So,
well, if you open up a terminal and you do a command with whatever the command is, it sort of activates sudo for so many minutes. So as long as you can run the script within that number of minutes, it's okay. Also, if the script calls for sudo, it resets the clock. So you can kind of get by it that way. But if you have a longer compile, for example, GNU Radio, which is about a 3-hour compile, there is a fairly long period of time where you're not actually asking for a super user do and or sudo, so it does create an issue. Also, with the default of, for example, let's see, WSJTX on the Odroid takes about 17 or 18 minutes to compile. So it's right on the borderline.
Okay.
Anyway.
Well, let me go on down the list. The next on the list is Dave Whitten. Go ahead, Dave.
Hello. Yes, I've been trying to, I don't know, I've been fighting with my own instances of the magnetometer boards and having an amazing amount of problems. But they're nothing generic to the, they're nothing about the design, I don't believe. They're just my difficulties with assembly. So I haven't really accomplished much lately, even though I've been trying and spending quite a bit of time on it. But there are two. I'm really not adding much to the calibration at this point, but Julius has been communicating some with Yeoman, but Julius has been very, very active, at least characterizing the what we have. Now, there's still a disconnect between, as I understand it, between understanding what Yeoman is expecting and what I think most of us would expect from the RM3100s. We get, at least we can characterize what the performance is to a fair degree with them, but we don't have the comparison to the Jenny Jump. At least we don't understand the comparison to the Jenny Jump unless someone has figured out something I haven't heard about. Also, for I don't know if anybody's noticed the new Odroid N2 Plus that they've just announced that runs a bit faster. They've just clocked it up. They've got a little better silicon or something. It's, it's just this competition, trying to be the fastest board out there, I guess. But it's not otherwise terribly different than the ones that people already have, except that it has the clock backup battery actually in a socket on the board. I don't think there's any other major difference, but it may well need a fan or something to run, at least at full speed. Other than that, I don't have a lot to report, but if anyone understands, has any light to shine on the difference between the results at Jenny Jump and the ones from the RM3100s, I'd love to hear about it. That's all for me. Back to you, Dave.
I wanted to mention that the emails from Jules, and I don't know how many people in the group are actually seeing those, are quite informative, and he seems to be doing some very interesting work. So I think, Nathaniel, you're in on that, Lou. So there are some good pieces there.
Yeah,
so,
I agree.
Next on the list is Dave McGaw. And Dave, you're next.
Hey there. I don't think I'm on that list. I haven't seen anything out from Jules.
Okay. It's sort of ad hoc. I think Holman is the one that just put the names in there, or Dave. I don't know.
Yeah, we should add you to that, Dave.
Yeah,
that would probably be really helpful.
any of that conversation, unfortunately. I'm hoping to get magnetometer running here shortly. Just need to solder the pins into the breakout board, and then should be able to try bringing the software up. So yeah, I do want to be able to help rationalize what we're seeing on the magnetometer. I do have one other thing to bring up regarding the magnetometer. I just realized we were going to fly one of these on a CubeSat that I'm helping with. So that bodes well for the sensitivity, but we're going to go to look at a different series, different principle, because we're concerned about the RFI from these. Now, of course, our application is different than sticking it on a CubeSat and having loop antennas wrapped around it. But once we do have it running and combined with receivers, we should keep a good eye on possible interference that it's generating, especially down in the VLF range. I'm not quite sure what its switching frequency is, but it's apparently of concern. So that's where I am. Back to Nat.
Okay. So next on the list, we have Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, Dave. I don't really have much to report. I've been trying to compile KiCad on my Mac, and I've been having trouble. But that's pretty much it. Oh, while I'm on the subject, for donating hardware to Tapper, would it be better to use something like KiCad or Eagle or something like that for board files versus Easy EDA? I don't know if any of you heard of that, but I was wondering if anyone has. It's kind of like a PCB layout software in your browser, but the problem is that the layout is stored in your account and you can't download it. You could export it to Gerber, but you can't download it. So I was wondering, what is the best
KiCad.
Okay. Yeah, because I saw that people made some really nice layouts, but there was no way to download the file, so I'll just stick with KiCad. In that case, back to the net.
Okay, and next on the list is Michael, AAK. Go ahead, Mike.
Oh, greetings to everyone on the conference. And speaking of hard drives, I've been doing a project upgrading a server with 11 terabytes in it. And I noticed that I decided to replace these drives. They've been running 24/7. This one is a Western Digital. It's been running for 6 years and 7 months. This one is a Toshiba, and it's been running for 7 years and 4 months. And this one is a Seagate, and 8 years and 7 months. So I got my money's worth out of them. Back to you, Dave.
I would say so, and you're lucky you haven't had a failure. So very good. Next on the list, it keeps jumping around on me, but I guess it's Terry, W0ASP. Go ahead, Terry.
Yeah, I got myself unmuted here, I think.
Yes.
I can start the video too, I suppose. Yeah, I'm actually kind of lurking here, but my kind of interest in this project is we run a amateur radio astronomy observatory here in Berthoud, Colorado. And we're putting up, we do 21 centimeter hydrogen line astronomy. And the more bandwidth you can get on that frequency, the better you are at picking up what we call synchrotron radiation, the really broadband radiation from a lot of the radio stars. And right now I'm using a AirSpy, and AirSpy will give me 10 megahertz, sort of, but it's terrible. The AirSpy engineering is horrible. The data you get out of it is very, very distorted by its IF filter, and I've had to work an almost infinite amount of tricks to try to flatten the spectrum out on AirSpy. But it's the only thing in a practical price range that will give you several megahertz of bandwidth. And I'm looking to try out one of these TangerineS at our observatory.
Sounds good. Well, any expertise you have to throw in, please do.
Well, I've done a little bit of HF here and again, and I'm kind of poking around with radio astronomy.
Okay.
What frequency did you need, Harry?
Oh, well, 1.4 gigahertz, but we will certainly do a down conversion. We can easily make a down converter.
Okay, because Scotty and Tom, they also have intentions of developing a number of different RF modules that can plug directly into the Tangerine. So even though it's not on the first order of business, you know, I'm sure they would be interested in developing a RF module that would support radio astronomy operations as well.
Oh, sure, I could do that too. It's just it's fairly straightforward. But
Yeah.
The hard part is 20 megahertz of digital bandwidth without distortions.
Yeah.
That's not too hard for us.
Yeah, that's what I'm hoping. Hey, when can I buy one of these things?
End of the year, probably.
Okay. Yeah, hook me in, because I've got a project that has a little bit of funding, and I can certainly afford to buy some of the early production units.
Well, with the grant money, maybe we can arrange to have you be a tester.
Oh, yeah, okay. Yeah, I can test them at all frequencies. I have an HF observatory Radio Quiet Observatory on Table Mountain. And I'm also using an AirSpy there, and with not very satisfactory results. I'm monitoring radio signal strengths from Cygnus and Cassiopeia A at HF frequencies.
Okay.
Harry, have you what bandwidth did you want at 1.4 gig?
Oh, if I can get
10 megahertz?
if I can get 20 megahertz, I'd love it.
Yeah, 20 is a bit hard off the shelf, but 10, would that?
A real 10 would be fine. An AirSpy has a 10 megahertz sample rate, but its IF filter is such garbage out at the end. I can only get about 6.
Yeah, I'm just wondering if you've tried the SDR Play receivers.
I really don't like those units. I've tried them. I use them for my VHF meteor scatter.
Okay.
But, I've not been able to get full bandwidth out of them.
Oh, that's interesting. No, because I was using them with 10 megahertz bandwidth at baseband or near baseband.
A lot of it's the software. You know, I use SDR Sharp with a Russian plugin that will let me download baseband data from the AirSpy.
Mm-hmm.
And it'll record the 10 megahertz and have a schedule to turn it on and off. But they have a horrible error in the code in that if you record data off the AirSpy in 16-bit integer format, it has a plus and minus 0 problem. And you get twice as many 0 values. You do the probability distribution function, and the Gaussian has a little nipple on the end, which is 3 dB above the.
Sounds like they have a 1/2's complement problem.
That's what I'm talking about, but nobody will answer me from that group.
That's funny. Okay, well, you'll be a critical tester on this one.
Yeah.
I'm willing to help.
So next on the list, I think, is Tom McDermott. Go ahead.
Oh, good evening to everybody in the group. Not much this week. I'm just anxiously awaiting Scotty's hardware.
Okay. Well, So I think the last one is Veronica. We're going alphabetical this time. So you're the last person.
All good. Hello. So this week I've been working on regenerating some graphs to look at geomagnetic storms with the RBN data and the WhisperNet data because initially they didn't really show us what we were hoping to see. So I'm kind of working on redoing them to look at the data a different way. So hopefully we can get some useful info out of it. And then also this Wednesday, I'm registered to take my ham radio test. So fingers crossed, but hopefully I pass. I'm excited. So
Good luck.
Yes.
Veronica, how long did you prepare?
So I was preparing a few months ago, but then with Corona, I was supposed to take the test a while ago, but it ended up getting postponed. So now they're offering it online. So for the last few days, I've been taking the practice tests on QRZ.com. So
Because I need to take that test as well, okay? And it has been postponed.
if MIT is offering it online, I can send you an email with the information. I think there's still some spots if you register to take it. But I can email you if you would like.
So how are you doing on the practice tests?
I just started passing them today, so I'm gradually doing better and better, but hopefully by Wednesday there won't be a question. I'll be good to
You
go.
only have to pass once.
Yes.
After,
The right one.
after PhD and after so many exams, I don't like the idea of test anymore, okay?
I know the feeling.
I have had enough tests, GRE, classes, exams.
I've had a number of my, I've convinced a number of my professors when I was in like grad school and undergrad to take their ham radio license exam, and I never saw people get so nervous as these people.
Well, Nathaniel, who was that guy from the government that you got to take his ham license at the first HamSci or second HamSci conference?
Oh, I can't take credit for him, but that was Volodya Papichavili. He was the NSF program director for the Office of Polar Programs.
Wow.
So, yeah, I mean that's a pretty high up there ranking.
Yes.
Yeah.
Oh yeah, I've dealt with him before. He rejected a lot of my proposals.
Yeah, we know who he is. I've met him.
Well, we're open for general discussion now. Does anybody have topics they want to bring up for the session?
Jonathan, you had a couple of questions in your email about the data rate for the VLF receiver. Scotty, did you see that email?
No, I didn't.
Okay, Jonathan was wondering, he's looking at maybe 16 megabits per second. I've got to go read the email from the 4-channel VLF receiver with 24-bit samples, and was wondering what kind of connector he might need, if the leaf was okay, or if he needs to use the RF connector.
That's a good question. Since I haven't assigned the pins on the leaf yet, because I've been waiting for the answer from Altera, which I now have, we'll have to see. I think 4 channels, I think we'll be able to do on the leaf connector, which is an M.2 connector. So basically on the leaf board, it's gold fingers. It's the connectors on the data engine.
Okay, all right, yeah, because in the email, so for 16-bit samples at 192 kilosamples per second, with 4 channels, it's 12.288 megabits per second, and for 24-bit samples, it's 18.432 megabits per second.
Can you do an I2S type interface?
Well, it is. It can either do I2S, or it can either do something new called TDM. it's new because it handles multi-channel audio, more than 2 channels.
Yeah, it's not really new. We've been doing this for years. It's standard multiplexed digital audio rates.
Oh, okay. All right. Yeah, I've only seen it recently, but I figured that would be the best bet, the best route to go, rather than changing between modes. You know, if only 1 channel is enabled or 2, I figured it's just better to stick with TDM for up to 4 channels, and that would make things a lot more simpler.
Yeah, the one reason it's a high bit rate is because you're doing it serial, rather than parallel. So, but other than that, yeah, system. I mean, others can say
bit rate's fine.
Yeah.
So we've done actually I2S, I2S, up to 30 megahertz with no problem.
Oh, okay. Because I haven't had time to look at the data sheet yet and figure out what the clock frequencies would be for the bit clock.
Okay.
But
you're still talking about the Cirrus part, right?
Yeah.
Okay. Yeah, because what the simplest thing to do would be to make sure that we connect up the proper pins on the leaf board, that we can just connect that part directly up to the leaf connector.
Okay. All right, because on that subject, I was wondering about power. What you had planned on running power on that connector, because the Cirrus part needs 2 or 3 different voltages, but I figured we could get away with 2 and make some filters. One voltage is for the analog, one's for the digital.
And for the analog, you're best generating it yourself off of a higher voltage and then filtering it well, and generate it on your board, because then you have control over it and you can make it as clean as it needs to be. And generally, digital voltages spread across connectors are bad candidates for analog powering analog circuits directly. So as a minimum, you'd have to filter it. And typically, the way the leaf was conceived was there's no power on the leaf connector. It's only ground. So the power comes off of the Raspberry Pi header. So you're going to get basically 5 volts and 3 volts there. And I don't think that if any of them supply 1.8.
All right. So then in that case, I should probably plan for a pin header that can provide external power. In this case,
I'd prefer you not do that. I'd prefer you do regulators on board and get your power from the 5 volts if you have to.
Oh, okay. Linear regulators or DC to DC converters?
Well, it depends on what you're going to use it for. If it's for digital, DC to DC switchers are okay, but you have to be careful and not let your switchers get into your RF. That should probably be LDOs.
Okay.
So we can go over that if you want to, and when you get to the point, and Tom is a great resource in doing that stuff too. He's an expert with the power supplies after having done the RF board, having had to have the same exact questions over again.
Okay,
Yeah, so,
all right.
So Jonathan, if you can look at what you think you might need in terms of supply voltages and currents, we can discuss that offline and figure out how to get there. I found that the low dropout regulators could easily handle the 3.3 down to 1.8. Things like that were pretty easy to do.
Okay. All right. Well then,
Jonathan?
Yeah.
I'll also point you to a new standard that Analog Devices has brought out that they called it A squared B. It's up to 50 megahertz megasample per second, megabit per second bandwidth and all that. Supports I2S, supports the TDM. It's kind of what state of the art today is for this type of interface.
Oh, okay.
And it might also give you some ideas of what would work as a good connector for it.
Okay.
Yeah, the M.2 connector is good for up to like 3.5 gigahertz. So it's a very high speed connector. It's very inexpensive. And any of the formats, if they're on standard voltage rails, we can handle the format in the FPGA without any trouble.
Oh, okay.
Within a reasonable frequency range.
Yeah. All right. Well then, what I'll do is, as soon as I get KiCad compiled, I'll start laying out a very, very rough schematic with power and all of the basics, and I'll just go from there then, and then I will contact you guys offline, and we could discuss it further.
And I can get you the pin out of the leaf connector as soon as it's done. And actually, this may be somewhat interactive because I want to make sure it supports what you're going to do. And then the Raspberry Pi connector is pretty standard already. It's got its own pin out defined. So as far as the power pins go, anyway. And I don't know if you need any other low speed I/O for it, because that would come off of the Raspberry Pi connector.
Well, is the leaf connector, is that something, is it going to be a like a Raspberry Pi hat, or is it, because from what I could remember, there were the two connectors for the RF boards, and then there was a third one, which was the leaf.
That's correct, but there's also a Raspberry Pi hat board. So the leaf boards are designed, should be designed to use both of those connectors, the Raspberry Pi hat board for power and low speed I/O, and then the leaf connector for the high speed I/O. So you actually slide the leaf board into the M.2 connector and then push it down onto the Raspberry Pi header, and you've got basically an extended Raspberry Pi header. So you have the 40 pin connector to the Pi, and then you've got the 75 pins on the leaf, on the M.2 connector on the other side of the board.
Jonathan, you may want to look at the video that's on the Tangerine SDR website of Scotty at the DCC last year. He's got the mechanical mock-ups of the modules and the connectors, and I think it might, it's only like 6 or 7 minutes. It might help you.
I can actually bring the document up here because we're on Zoom. So if we have time to do that, unless there's something other people want to talk about.
This sounds like a good thing to talk about to me.
Okay, so just.
I told Jonathan I really like the idea of adding the VLF capabilities to the system, and I know a number of other people like Bill Lyles is very much a VLF enthusiast as well, and it's a very important part of the space science community as well. So I told Jonathan I'd provide him, support and resources for the development of this as well. So.
Okay, let's see if I've got it here. Yeah, okay, this may be, okay, so can I share my screen here? Let's see.
Yeah, you should be good to go.
Okay, so can you see this slide here? Can everybody see this slide?
Yes.
Okay, so the red outline here, well, it's actually an orange outline that goes across. It's in here. That's the Raspberry Pi hat size board. And then if you extend it out to the right and down, and these dimensions are all TBD right at this point, there's an M.2 connector down here. that has the high-speed I/O on it, because the FPGA is inside here. So this will connect directly to the FPGA on high-speed lines, and there'll also be some low-speed and some power lines up here to the standard. This is standard 40-pin Raspberry Pi header up here at the top. And then in blue, the two RF modules are behind on the back side of the board with the data engine in the middle. Creates like a 3-high sandwich of boards.
Oh, I see.
And then the clock module is down here on another M.2 connector that makes a 3-board high stack down here also. And this one here is deleted. We're not going to do this. This is going to be an MEC connector for the SDR stick boards, but I don't have enough I/O to do it, and it's only for the first debug anyway. And since Tom has the RF board already done, we're going to pretty much get RF boards and DEs at the same time, so it's not really necessary. So this is going to be removed.
Okay.
So to give you a better idea of how it's going to plug together.
Yeah, yeah. Now, if you were going to use a Raspberry Pi, you would connect it on top, and then the Raspberry Pi was going to act as the what's it called? The LCC portion of this.
Right, but keep in mind that Raspberry Pi low-speed header does not connect to a Raspberry Pi. It connects, or it can, but it can connect to us also.
Right. So I guess, John, so there is no Raspberry Pi here. This is just, you are just having an input that is the shape that could accept Raspberry Pi hats if you wanted to. But there's no actual Raspberry Pi here.
Right. Raspberry Pi is connected with Ethernet. So
I see.
So all of the LCC, Jonathan, is going to be off board of this. So right now they're planning on using Odroids instead of Raspberry Pis for this, but it's going to be separate from this board.
Oh, I see. So that's just a connector that can accept Raspberry Pi hats.
Correct.
Yes. Yeah.
All right.
It's a convenience thing.
And leaf boards too. And the leaf is just an extension of the Raspberry Pi hat I/O, since it has the 2 connectors. The M.2 connector there for the leaf is not intended to ever be used by itself. It's always intended to be used with the low-speed I/O connector up above.
And that M.2 doesn't conform to any standard.
That's correct. It's an M.2 connector, but that's
use
it.
It doesn't correspond. I mean, if anyone tried to plug an M.2 standard, is that a M.2 there E or N?
I believe it's a B.
B, okay, because those usually have defined USB and some other stuff, all kinds of things on them.
And that's good. That's a good warning, Dave, to give. Don't plug your SSD into one of these, because it's an M.2 connector, but it's not in an SSD interface or any of the interfaces that reside on M.2 connectors. It's the Tangerine interface on an M.2 connector. And of course we have 2 of them, because we have another one down here for the clock module. The reason I picked these is because they're so inexpensive and they're so high performance, it's hard to resist. And if you look, the physical form factor of the boards resembles no commercial off-the-shelf boards that use the M.2 connector. So it'd be a stretch of the imagination to think that you could plug in an SSD or something and expect it to work, because it's physically not, it's not the right configuration. Not to say somebody won't do it. I mean,
I was going to say, Scotty, I can tell you my younger self would have that kind of imagination.
And if it fits in the connector, it must work, right?
That's right. I mean, if you look at the red Kataya, doesn't it have certain headers on there that, like, doesn't it have eSATA ports or something that aren't actually eSATA?
Yeah, no doubt. And then you get yourself into big trouble. But
yeah. So I mean, it's, there's going to be somebody out there.
So we need to set up the warranty department now. Is that what you mean?
The board looks big enough for if I need some LDOs, I could put them on there, and it looks like that there's plenty of room. So hopefully that
this gives you an idea of the size of the main board, and this is the leaf module here.
Oh, those dimensions are.
These are TBD. These will be especially location of the M.2 connector, because it's going to depend upon the layout of the data engine when we do it. But I expect the size to be approximately the same as this. The 56 millimeter and the 75. Well, the hat is actually less than 56 millimeter. I think it's 50 or 52, and the 75 is actually wider than a hat is. The hat actually cuts off back here somewhere.
Right.
But obviously, if we put the connector over here, we have to have the width of the board unless we make it some funky shape, which I'm trying to avoid having to do.
Okay. All right.
We may have to move things around slightly to get them to fit on the data engine. So,
Scotty, scroll down and show him your copper pieces.
oh, this guy here.
Yeah.
So this is the copper boards lacking any PCB traces. Like I say, this is a working model, only minus the traces on the board.
Oh yeah,
it was a joke.
Yeah.
Anyways, I just cut these out of copper so you can see the relative sizes of them.
Okay. Yeah, then
Actually have them, I think, plugged together here. And again, this connector is going away here. The FPGA will be here. This connector, and there's one underneath here. They go for the RF boards, which are underneath here, and they come out the backside with the SMAs. So this is actually two RF modules plugged in. And then the Raspberry Pi, the male header pins here, and the M.2 for the leaf right there.
Okay. Yeah, there's plenty of room. Like if anybody else wants to develop a board, that there's definitely plenty of room.
Yep, that's what we're hoping, is that there's enough room to do something useful. Sounds like this is going to be it. And if the interface, the only thing I think that would preclude you from doing it on the leaf board is a couple things. If you run out of room, because the RF modules are bigger. If you can't get the power you need on the connector here, that'll be a stopper. And the only other thing is if you couldn't get the enough high-speed I/O on the M.2 connector, that would be a stopper too, because there's lots of that on the RF module connectors. Not so much on the leaf, because you're really using it as a function it wasn't intended for. But I think it's a good solution because it'll be inexpensive, and actually you're going to have to figure out where you want to put the antenna connector. And I would advocate, if you can, up here, because this side and this side are going to be the I/O sides. And I really tried to avoid having I/O on two opposite sides, because then it becomes problematic how you build a box to fit it. Because the connector sticking out on both sides, how do you get it into the box? You end up having to have some kind of clamshell arrangement with cutouts, and it gets a little more difficult.
Scotty and Dan are used to that.
Scotty,
If it was easy, anyone could do it, right?
Are there
how many
holes that are not shown on the
Sorry,
mock-up?
Bill?
Are there mounting holes that are not shown on the mock-up?
They are not shown in the mock-up because we haven't figured out where they're going to be. You can see the mounting holes for the Raspberry Pi and the Leaf are there. Yeah. For the main board, they're not shown yet. My guess is there's going to be one in the middle here, there's going to be one up here, and there's going to be one over here, and probably one over here. So one on each side, likely. And you'll additionally have these two, so you may not need one here, because these two for whatever you have on a Leaf board can also mount the data engine. So that'll take care of that side.
Jonathan, how many RF connectors do you need on your VLF board?
I was going to put four four of the input channels.
4 RF connectors.
So that'll never fit there. So you're going to have to do it either right angle ones here to come off above the data engine, or you're gonna have to come off one of these other two sides.
Well, we'll see. Since this is VLF, there's some freedom with what I could use. I don't have to use an actual RF connector. I could use. My intention was either screw terminals or some sort of an audio connector of some sort, or a header.
You could use like vertical RCA jacks or vertical just 2-pin headers. They make nice ramp lock headers that are 2 pins wide. You could put 4 of those on there, and you could, if they're vertical, you could put them anywhere.
Yeah. Yeah, I'm not really sure yet with what I was going to use, but I was planning on something small, not very bulky, and maybe something that could fit in, say, that could connect to jacks on the case. But I'm not really sure yet exactly what I was going to use. But
are you running differential or single-ended?
Well, that was also another option. I could do both, or I could do either or, and I'm not sure yet. I was planning on single-ended for the first version, and maybe differential. Change the input stage, but I was planning initially on single-ended inputs.
Yeah, well, I would recommend you go differential from the beginning. Much lower noise.
Hey guys, I'll be right back. I have to move my truck from outside. I'll be back in about 2 minutes. Somebody's upset with me, so.
Yeah. One thought for a small connector is a miniature XLR. They're a little pricey, but they're good connectors, and they're differential.
These will have. I was thinking of putting isolation transformers on the board. So they're technically going to be.
Well, what bandwidth are you running? I mean, what's the lowest that you're going to be doing?
Well, I was planning on something like probably like 30 hertz to around 30 kilohertz.
Yeah, that's a pretty tough transformer.
Yeah, especially on the lower end.
Yeah, that's what I'm thinking. You might want to just try to run transformerless differential coupling.
Well, I'm going to need some sort of isolation anyway from the VLF preamps, because that could inject 60 hertz noise. So I'm going to need some sort of isolation anyway. EdCore makes some really good quality audio transformers with much better performance on the lower end. Right now, I'm using smaller ones from Triad, and their performance on the lower end isn't the best.
Right. You're talking a pretty good quality microphone transformer.
Yeah, yeah. I have some samples here that I was going to use in a deployment, and I figured I would give those a try. So.
Yeah, getting the low end and the high end, and you're wanting to get to 100 kilohertz, I presume.
That would be the hope. At least 75 kilohertz. That would be the hope.
Oh, just some of the design considerations.
Yeah, yeah. It's that's a detail I still need to hash out. Oh, and I have a question for Terry, if he's still here. Well, if he left, it's no big deal.
It looks like he's still on, Jonathan. Maybe he needs to unmute. But I still see him on the participant list. Terry, are you there? Oh, maybe send him an email off later.
All right. Yeah, I was going to ask him if he did any data processing on his well, he was talking about pulsars, and I was wondering how he did his his dispersion. I know that there's software to do that, but I was wondering how he did it.
I have a question for Scotty.
Go ahead.
So, are you still deep in hardware design, or have you even thought about doing any Verilog stuff?
Almost done with the hardware design. And yeah, I'm constantly thinking about doing Verilog because I want to get busy on that because there's lots to be done. There's many things I can do, but there's also a learning curve here. So you were talking about a like a flashy light test on the dev boards. Are you still up for that? Sure. That would be easy to do. So you want just a program that we can load that flashes the light, two different programs that do different things?
And then I'd have something that I could work on loading into the flash memory.
Okay. But you'd have to have the bootloader there too in the FPGA.
Yeah, I'm thinking of the dev board.
Oh, okay. I was thinking of IQ2, so sorry.
With the dev board, we have everything we need to be able to load it, right?
Well, you still have to have the bootloader, right? Because it's got to talk UDP and those commands, yeah. But we need that anyway.
Yes. So I think I'm set up for that, but I'm set up for the old system.
When you're using the Max 10 with the two Ethernet ports on it, right? The ones that we bought around.
I think UI and Dan bought one.
Yeah.
But I wanted to get started, but I need to know exactly kind of how it works before we just have to write a piece of code that plops things in it.
Well, so we need to flesh up the spec for the programming area.
Yeah.
Right. So we know what commands we're going to use and how we're going to do it. It's going to be basically the same as HPSDR, right?
That's what I was going to start with, but what I want to do is the FPGA environment slightly different, although it's the same company, and it's 10 years different.
Oh yeah, it is, isn't it?
Well, I think you might be looking for me to provide the use cases for the how to command the data engine to provide what the local host needs. Sounds like.
Well, this is simply, that'll be part of it. But the first thing I want to do is just write bits into the flash.
Sure. Right. Yeah. Step one.
Yep. And we were talking about some trivial program that, that you wouldn't need a whole bunch of test gear to know that it actually works. So if it flashed LEDs,
Flash
then
the
you
red
knew.
LED with one. It flashes the
Right.
green light with the other so that you can load one and then verify that you loaded the other because it'll switch.
Right. So I wanted to get that back on your horizon.
Okay. So that's the first thing that we'll do. Yeah, because that's really the first thing that I need to do anyway. I need to talk Ethernet.
Right.
Right. And the first thing you need to talk is loading the code.
Right. And, you know, yes, I did it once, but
so it should be simple the second time, right?
No, there's a few bugs to figure out along the way.
Usually much worse the second and third time.
Yeah.
Much worse, yeah.
We're all 10 years older.
But haven't you heard old age and treachery will overcome youth and skill?
Well, possibly.
There's also another saying that wisdom comes with age, but sometimes age comes alone.
So today I got a package that started out in New York City, and then it went to Massachusetts, and then it was coming to me in Missouri, and then it went to Indiana, then it went to Santa Barbara, California, and then it went to Claremont, California, and about 3 weeks later, it finally got to me today.
Did somebody have the wrong zip code on the package?
Nope, the address was perfectly correct. It was the Postal Service that did it, but I was surprised. I had another package I ordered about a week ago that got here the same day, and coming from New York as well.
I bought a Drake 2B from a guy in Florida coming to Arizona. And it didn't come, and it didn't come, and it didn't come. And finally, I called the guy, and I got verification that it was mailed. I called UPS because it was a UPS deal, and they said, well, we delivered it. And I'm going like, well, you might have delivered it, but it wasn't to me. Well, so here's what happened is, now this is like a period of 2 months has gone by, and they're saying, well, basically, we're just going to pay off. We're going to pay the insurance because the guy insured it for what I paid, which is $200. Well, he would get the money. So now he got the $200 that I paid him, and then he gets the $200 insurance money, and I don't get the radio.
And it's a Drake, so you can't just go buy one.
You can't just go buy another one. It's a historic radio, right? And so UPS is offering to pay him off. And so what I did was, and they said they delivered it. So my address was 7634 South. It was on 41st Street in Phoenix. Well, I went to look to 6634 South. There was no such address, but there was a 5634. And you're not going to believe this. Now, 2 months later, I go and I knock on the door at 5634 South. I got there a half hour after the UPS guy got there and collected the package that had been sitting there for 2 months in the guy's laundry room, not knowing what it was or why he got it. And they delivered it to me.
Oh, wow.
So I got the radio after 2 months. But the upshot was that they refused to deliver anything to my house again without a signature.
Oh.
Because after all, it was my fault that they delivered it to the wrong address.
Right.
Sure.
I ordered some. Go ahead.
I did have a question about the data engine. We touched on this last week, but I never heard anything more. Do we want to have any reporting of any of the parameters of the data engine, like temperature or voltage or anything like telemetry?
Yes, I think that should be included in some of the commands that we're going to implement.
So what things would you like me to specify in the spec?
I think I'll have to let you know because we're going to have to figure out what it is I can give you.
Well, sure. But, I mean, is there a temperature sensor on the board that you can read?
Yes.
Okay. And a voltage
and
sensor?
No, the problem is that the voltage sensors I took off because this is an irritant to me. In the Max 10, if you use a single analog input, you lose all 16 inputs for digital purposes. So basically, if I wanted to measure the 5-volt input or the 12-volt input or whatever voltage I wanted to measure, I would lose 15 other digital I/O inputs, which was not, this was not clear in the, you have to really drill down in the data sheets to figure this out. That when you turn on the analog subsystem, you disconnect all the digital I/Os and you connect them up to the analog subsystem, and then I can't come up with 16 analog things I want to read. So I opted to say, well, let's just not do analog. We do have a temperature sensor, but I'm not going to read the analog voltages because I don't have enough digital I/O as it is, so I don't want to sacrifice more of them to be able to read the.
Can you think of anything else that you would want to use, that you would want to sense on the device that
Well,
you could actually do?
I think that we want to be able to report firmware revision and things like that.
Yes.
And perhaps that'll be stored in the I2C ROM that we have on board. Because remember, we have a unique 76-bit serial number that that we're guaranteed. And,
okay, so the data engine serial number might be something to report too.
Right.
And essentially, you want to know what boards are connected.
Okay, yeah, so like
to the data engine.
A hardware query.
Yeah.
And you'd likely want to know what firmware is actually loaded, right, into the FPGA, because there's going to be multiple different versions to do different things.
Yeah, if we're talking about general cases, for example, the RF modules have SPI or to program the ADC converters. And so we're going to need some way to set up, program, and read back the SPI registers on the various different kinds of modules plugged in. It's probably another general case.
We have a red LED and a green LED, a bicolor LED next to each RF module connector, so that if the FPGA code reads from the RF module its function code or serial number or whatever we choose to put on there, and it doesn't understand what it is, it can light the red LED. Now, it won't tell you what to do. It'll just say, I don't understand that board that's plugged in there, so you better do something, fix it. As opposed to, oh yeah, this FPGA image understands that RF module, green light, you're ready to go.
Is there any way you can report this information you're wanting to report back in an open-ended way? So, kind of like SNMP or, something where you don't have to, it's not like fixed field reports, so that you can embellish it in the future.
Oh yeah, that's a good idea to add whatever we need to add. Like, what was Phil going to do, Dave, with the RF board? I mean, with the system description, he was going to have he's going to have a. What was it? What was the format? It was going to be XML, wasn't it?
I think it was XML, yeah.
But that may not be the best solution today. I don't know.
So, speaking of Bill, I was talking about the magnetometer on OpenHPSTR Friday, and he said, "Oh, that'd be interesting." And then he started thinking about it. He said, "No, I can't test the magnetometer because he has 100 kV lines in his backyard."
Well, you could test the fields of the 100 kV lines.
Yeah, he could. They're huge power lines. I said, you're a ham radio guy. Why did you buy that house? And he said, I bought it before I became ham.
Well,
I have
high voltage is low current, right? Low magnetic field.
Well, I have 78 kV lines across the street that I live on.
Yeah.
And they're very innocuous because there's only one wire running across the top of the poles, but they're kind of bigger poles than regular power poles. And let's just say that my 160 meter balloon mounted antenna has become friendly with the 78 kV.
Oh no!
On more than one occasion.
That would be entertaining.
I'm a slow learner, and I did it 2 times.
Did you get a charge in your radio?
Well, the first time, both times it vaporized the antenna wire.
Yeah.
So it was gone. The balloon went off to, Timbuktu somewhere. And the first time it burned all of the ground traces off the power supply in my Omni 6. And I mean, they were just gone. And they're 1/2 inch wide traces from the fuse to the power. And the fuse, when you took it out, it was completely black. So you couldn't see anything inside it. But that was an easy fix. That was just a few wires, and the radio, believe it or not, was okay.
Wow.
But the reason is I had alpha delta RF switches, and I had the antenna grounded
Oh.
when it hit. The second time, I was operating the radio, and there was this like explosion in the back, and then there was silence. And I'm thinking, uh-oh, this does not bode well for the radio. Well, it turns out the only part that fried, I was using the Hercules amplifier at the time. It blew out the vacuum relay in the Hercules amp. $250 vacuum relay. Vaporized one of the contacts. But the amp and the radio, once I replaced the relay, they work fine.
Yeah.
It's a miracle. And I don't put antennas up here anymore like that because
Yes, I could imagine.
too dangerous. I'm not smart enough to have an antenna like that.
Didn't Benjamin Franklin do something like that?
I got it. I'll put it up in the lightning storm next time.
Yeah. Well, you want to detect lightning, right?
Yeah, really. There you go. Anyways,
another
the new place that we're working on has all underground utilities everywhere. The nearest power lines are 1.5 miles away. So high tension lines. So I think my neighbor is a ham, and he turned his flex on and hooked up to his hex beam. And during the day on 20, the noise level was S1.
Oh.
So I'm looking forward to moving in more ways than just moving. I mean, I have to go through this move thing again, right?
Yeah, but this is yourself, not a business.
And it's supposed to be like in February, when it's cool out, not like in July.
When it's only 90.
Now
It's only 90, right?
Does it rain in February?
Yeah, a little bit, January, February.
Cool.
But
cool is not cool is not the term we use around here in February in New Hampshire.
Well, yeah, at least there won't be any snow on the ground. But you know what's going to happen is there's going to be construction delays and it'll be June. That's what's going to happen. I may have just hexed it, but
There was another question that came up, and this is kind of for Nathaniel. Nathaniel, we've got you on the line here. We talked a little about where is the best place to store documentation. Do you have any definitive answer on that, or is that still being discussed?
No, I do have an idea on that. So I think there's kind of two things going on here. One is Tangerine SDR is technically like Tapper's project. So they are the ones that really have Tangerine SDR, even though it is inspired and heavily funded by HamSci. So so the Tangerine people in Tapper will be maintaining Tangerine SDR documentation on the Tangerine SDR website like they have been. However, at the same time, the HamSci personal space weather station has to be its own thing and also has to have its own documentation. So I have created a Google account called hamsci.psws that I do have a Google Drive account there. And so anything that is, what I'm planning on doing is I'm planning on mirroring the Tangerine SDR documentation that's pertinent to the personal space weather station. I'm planning on mirroring that onto the HamSci Google Drive. And then in addition to that, anything that is personal space weather station only, it needs to also go on that HamSci personal space weather station drive. It's also welcome to stay on TangerineSDR.com. It can be in both places, but we have to have a complete set of documentation for the HamSci personal space weather station on the Google Drive, and then the Tangerine SDR webpage should have the documentation for Tangerine SDR and whatever additional documentation they also want.
Does the Google Drive system allow you to maintain a revision history like some systems do, like Box, for example?
I think it does. I'll take a look at that more closely. So I think it does have a certain amount of revision system to it.
Because the specs, we got into this discussion with Christina, the specs we have on the tangerine.com website are kind of relatively old. So we were thinking how to maintain everything in sync into the latest version and still maintain history and all that stuff.
Right.
Well, we do have the older versions. So the one that's in the folder is the last touched, and then the older one should have been rolled over to the old file on the Tangerine. I don't know if you've been doing that.
Well, I don't have the privileges to do that.
Okay. I know Tom has access. Scotty, you have access
Okay.
to the Tangerine.
I haven't done any of the archiving either, so.
Yeah.
So I've just been manually rolling
Okay.
over older versions of the documents, but it's a manual process, and it's just a folder full of old documents, none of which are linked exactly to the current versions. It's not like a revision control system.
No, but at least we have it all, hopefully. And Nathaniel, you asked me to start a white paper thing, and I was debating whether the white paper should be in with the documents or should I just make a web page of white papers?
Yeah, which white paper are you talking about?
There was one on email a week or so ago.
Yeah, Tom's one on the moving some chirp functions into the FPGA.
Okay.
And that just brought up the question, should we have a place on Tangerine to hold white papers?
Yeah, and I believe we should, but my question was, would it make more sense to put it in with the documents, or would it make more sense to have like a separate info page for other people?
Or even just a directory for white papers.
Or you know about white papers that are all related to the Tangerine, or just white papers?
We only have one right now.
Yeah, just Tangerine ones, Bill. Sounds good to me. Just a white paper directory on the Tangerine site.
Okay, I'll do that.
Until such time as we get a plethora of them and we have to sort them somehow.
Right.
All right. Well, I'll as time goes by, I'll get a more complete set of the documentation that covers like the functional specification, detailed specs, and all that stuff, and make sure you have an up-to-date copy of all that if you would like to maintain it on the tangerine.com site. But we're planning on putting that on the Google Drive too, I think.
Right.
Bill, what is your Google, your Gmail address?
Okay, I'll have to look that up. I rarely use that. Okay.
Wait, I have it. It's AB4EJ1.
Yeah, right, okay. Yeah.
Say, Tom, we're past your deadline.
Yeah, I probably need to bug out here. It's I've got 11 minutes to get the notes done and get out of here. So we'll see everybody next week.
Okay.
Good night, Tom.
Okay, Tom.
Good night, Tom.
Good night, Tom.
My other question was, Dan is producing all these scripts, and I was wondering, where's a good place for me on Tangerine to put scripts?
How about a script directory?
That would
Sorry.
make sense.
Scriptorium.
Well, the only thing is they may need a bit of explanation what each one is, unless people are used to reading Linux scripts. I mean, it's no problem for me, but
Probably need to put a README file or two in there with them.
So maybe for each functional script, you have a directory that is a README file, and this is starting to sound a lot like GitHub, isn't it?
yes,
Yeah.
we
Sounds like-
could do all this on GitHub too.
Sounds like a good solution to me.
Well,
Didn't
for
we have an
code,
argument against using GitHub for some reason? What was
What?
it? Didn't somebody have an argument for not using GitHub a long time ago and far away?
Maybe Bruce.
Probably
Bruce,
John
but-
Ackerman. You know, the Tapper GitHub, it kind of, Anna set it up, and then it kind of just ballooned. And it was hard. It was really hard to manage the old SVN stuff in there. And
yeah, my problem with GitHub mostly is that most every GitHub site I've ever viewed has just been a giant room full of stuff that's all been thrown in, and there's no explanations of what is what, what's the latest, what pieces do what, and it's great if you know what you're looking for, but if you don't know what you're looking for, not so good.
Yes.
But it doesn't have to be like that.
No, it
there's
doesn't
all
have to.
kinds of options for having, you can have an associated simple kind of a little wiki, I think, or not, maybe it's not a wiki, but it's there's additional components that you can put together that provide a lot of that kind, at least a place to do all that kind of explanatory stuff, and just a README MD file in each folder that's maintained, can go along.
So Dave has done a nice job with his magnetometer software wiki, in that there is a lot of documentation how that software is used.
Gets harder and harder to keep it up, though, as it gets longer, but there's no way around that, I don't think.
It's always the case, yeah.
Yeah.
So really, one of the nice ways to deal with this is, if people are developing projects, they can run a wiki, GitHub by themselves, and we can just link to it from the Tangerine page.
So a page of GitHub pages.
Yeah.
Yeah. Yeah, you can.
The other nice thing about putting things on GitHub is it's easy to clone them.
Yes. Every clone is a complete copy of the repository with the history.
Yeah.
And you can transfer ownership of them if ever you should want to, like to the group or something like that in some way. I know there are options for that.
Yeah.
So
now,
be careful, but.
And years ago, you had to have a actual purchased account to have private directories. Now you can have private or public directories as a normal person without paying.
I've always paid, and they never stopped charging me when they switched that.
Well, no one here is normal anyway, so.
They give free accounts to academics now too.
Yes.
Oh.
Which is
They just want to own that.
It is awfully convenient. Oh. Do you have that just ready?
Oh yeah.
Or is this part of your nerdy day?
Yeah, I have like an XKCD cartoon for everything.
Oh, okay.
Yeah. Yeah. It's the alt text. The alt text is always. Yeah. So
this sounds like a Calvin and Hobbes revision of history.
it sounds true to me.
That's right. Like when his dad told him that back in the old days there was no such thing as color, everything was black and white.
Yeah.
That's why all the old photos look black and white.
I believe it.
So I saw this guy give a talk, and he said somebody claimed that he was a very Chicago type guy, and he goes, "I've never been to Chicago."
Oh.
So anyway.
All right, are we done here?
I think we are.
I think so. Good luck, Veronica.
Yes.
Thank you.
Good luck.
look forward to that call sign. You're
If when you pass on Wednesday, you'll get your call sign probably before next Monday.
I hope
Yeah.
so. That would be great.
Oh man, we used to have to wait what, 4 to 6 weeks to even find out if we passed the test.
I took my novice in August and I got the license in November.
oh boy.
Right.
And I was 14, and that was a long time for a 14-year-old to wait to get their license.
Yes.
Boy, yeah.
And
So
fortunately, my guy who gave me the novice test, he wasn't supposed to, but he looked at the test and he said, you passed. But he wasn't supposed to tell me if I passed. So you could get a notice in November saying you flunked and you're out.
yeah,
Wow.
Gotta
That's
start over.
a very long time to
Yeah.
be wondering if you
it's
passed.
usually a week or two now. But
I think when I was reading all the directions and all how it's gonna go and stuff, it sounds like I'm gonna find out if I passed right away. So
Yeah.
I
Okay.
should know. But
Yeah, they'll tell you right away if you pass. It's then how long does it take for you to actually get your call sign?
yeah.
that I
That
I think the
Now-
last one the Explorer guys did, it only took like 3 or 4 days.
Are you in Scranton?
I'm in New Jersey.
Oh, so you'll be two-land, won't you?
Yeah, I think W2. It's definitely 2 where I am. Yeah.
Yeah.
Yes, that's two land.
Yep.
Yeah, I need
Princeton
to
was
try and
W2PU.
talk my students into.
So if you don't
Sounds
pass,
like-
will they let you take it again right away, or do you have to wait?
I think I have to wait again. I don't think they let you take it again on the same day, but they did say that if I wanted to take the test right after for a higher license, I can do that. But I
Yep,
don't
yep.
think I'm going to. Do
So
that.
I was a VE one night and one of the examiners, and we had a student walk in and took all 3 all the way to extra one night
Wow.
and passed all of them.
Hey,
Yeah, my grad school roommate did that.
Yeah.
when I got my general, you had to wait 2 years before you could even take the extra exam. 2 years.
2
So-
years.
And
Wow.
2 years and 20 words per minute.
Night.
And 20 was-
Oh, Robin did them all in one night.
Yeah, I went in and after I passed the general, the guy said, "Well, there's nobody else here. You want to try the extra?" Sure, why not? He says it won't cost you any more. And I had gotten bored out in the parking lot, and so I read a few of the quizzes for extra level, and I just barely passed the extra. I mean, I didn't know anything about the, I mean, it was more luck than skill, but.
Was there any code involved?
Short-term memory works wonders sometimes.
There was a book that came out when I was getting my general, and it was teaching you enough Morse code to pass the technician, which is 5 words a minute,
Right.
on the way on the train down to New York City. 45 minutes. They claim you could learn the code well enough to pass the test. You, of course, the next day you remember nothing, but you could pass the test.
Well,
I'm
I
not
did.
sure that's really true, but
I did get my novice license in '75. So
Yep.
So
Well,
I
I'd be impressed if somebody walked in with no license back during code and
Oh,
went
yeah.
all the way from
yeah,
technician.
Well, you had
to,
you had a lot of military operators back then, right?
Yeah,
Yes.
that's true. Someone
Yeah.
could do that.
I mean, I
But
remember
I
like
did,
the first field day I went to. One of the guys there, Ray Linky, he was one of those old military type operators, mill operators, where he said that he did a college correspondence course while operating the mill in the military. So you could just read and copy code to a typewriter, no problem.
yep.
right?
Yeah.
Well, my
I knew
story
some
is I
guys-
did tech, and then 3 months later, I was going to do general and advanced, and I did that okay. And that, of course, was upgrading to 13 word per minute code. And then they said, "Oh, you aced the advanced test. You want to try extra?" I said, "Well, I haven't studied, but sure." I passed extra, but then I was on the hook to learn 20 word per minute code. It took me a couple of tries to do that.
Yeah, oddly enough, I got my second class telegraph license before I got my extra. And because I had to go over to San Diego because they weren't giving any tests here in Phoenix. So I went over to San Diego and I took the test, and it was 20 words a minute plain language and 16 words a minute code groups. And you had to pass both tests in order to and a sending test, which I brought my own electronic key, but the guy made me send a full minute worth of text. And I got like 75 characters, and I made a mistake, and he kept going until I got the 80 characters or whatever it was. But on the receive test, I copied the 20 word a minute plain language solid. The 16, I barely passed because code groups are so much harder. You can't fill in any letters.
Yeah.
And so I got that, and then I left. And I came back later to get the radar endorsement. I got that, and then I said, well, can I take the extra? Just as a whim, I said, can I take the extra? And they said, no. And I said, well, why not? And because it was a Thursday, and they only give extra tests on Wednesdays. And then they found out I had a second-class telegraph, and they said, oh, never mind, it's okay, because it was the code test they couldn't grade. So they couldn't do it on a Wednesday, except on a Wednesday. So I took the test, and I passed it. So, but it was a lot of years later, because I got my advanced in 1969.
Yeah.
My novice in 67, general in 68, advanced in 69, and then extra in 83.
Yeah.
So, but that 20 word a minute code test, I don't know how long, David, it took you to get up to that, but I found that copying W1AW didn't do it. I had to actually make QSOs, or I could not get the speed up. It just didn't work. So
yeah, I was using W1AW, and I just barely passed it, but it took me 3 tries, I think.
My problem is I couldn't write fast enough, which actually means that you can't translate fast enough.
Yeah.
So.
All right, friends, I'm going to call it a night.
Yeah, it is.
Enjoyed it.
All right.
We'll be in touch.
Good night,
Good
everybody.
night, everyone.
With
Good luck
slides
for
and everything else.
Thanks.
73.
Good luck, Monica.
Night all.
73, everyone.
Every
Bye.